Okay, I think we'll get started. I see 21 people have called in today. Thanks to everybody for showing your interest in this talk, which will be about the NASA PDS Geosciences node services for distributing data to our user community. My name is Ed Guinness. I'll be joined today by Dan Scholes and Tom Stein. So it'll be kind of a tag team presentation. Tom, can we go to the next slide, please? Okay, I will be giving an introduction to the presentation. Hopefully I won't be taking a lot of time. The bulk of this workshop or presentation will be explanations and demos of 3 of the nodes data services for locating and downloading data. And that part will be given by, as I said, a tag team between Dan Scholes and Tom Stein, both of the Geosciences node. We'll end up with questions at the end if people have them. And if some of you have signed up for another workshop this morning, feel free to leave if we go long. However, I believe this Zoom meeting is open for an hour and a half. So if there is discussion that continues after the hour and you have time to stay, we'll stay with you until we can answer questions you may have. And if you have follow-up questions after this workshop, the last slide in this presentation, which you should have gotten in an email this morning, has information on contacting the Geosciences node if you want to ask further questions after the workshop. It also has links to the tools that we'll be talking about. So don't feel like you have to be scribbling down web links and things of that sort. So I'm going to talk for about 8 to 10 minutes, and then I'll turn it over to my colleagues, and they'll spend 12 to 15 minutes on each of the 3 tools you see listed there, explaining what they are and giving short demos of each of the tools. So let's get started. Tom, next slide. Okay, as I said, we are part of the NASA PDS Geosciences node, excuse me, which is located at Washington University in St. Louis, Missouri. And we are part of the Department of Earth and Planetary Sciences. We are focused on archiving and serving out data from or relevant to the study of the surfaces and interiors of terrestrial planets and their satellites, namely the Moon, Mercury, Venus, and Mars. And in the future, we'll be working with some missions for a couple of the satellites of the outer planets, in particular the Europa from the Europa Clipper mission and Titan from the Dragonfly mission, which will happen later this decade. There are 2 things that we tend to do. One is getting data into the PDS, in that we work with data providers, both missions and individual scientists, to design their archives, help them design their archives. Then we receive them when they're ready for delivery, validate them, put them online, and integrate them into our data services. And with the emphasis now for making data from research available to the research community, we are working with many individual scientists to help them archive their data within the PDS, particularly from NASA-funded programs like the PDAR program. And really the focus of this presentation is that we also work with the science community to help them access data through a series of services that we'll talk about today. And also we provide what we call expert help in understanding and using the data. The node has several scientists who are involved with several of these missions and are actively doing planetary research and understand many of the data sets that are housed at the node. The node, it's not listed here, but the node currently has approximately 250 terabytes of data within its archives and several tens of millions of products. Next slide, Tom. Thank you. These are the active missions on the left that we're archiving data for. There's probably several dozen instruments involved with those missions. Of note, the Mars Express mission, we serve as a mirror site to the ESA archives for that mission. And on the right, we see developing missions, that is, missions that haven't flown yet, but we're working with to plan their archives. The Mars 2020 rover is scheduled for launch next month and arriving at Mars early next year to start collecting data. Europa Clipper should arrive in the Jupiter environment and start collecting data later this decade. And Dragonfly to Titan, which is a drone-like experiment, we'll get there in the early 3030s. Not listed on this slide is another initiative we're getting involved with, and that is the Commercial Lunar Payload Services, or CLPS, which involves several missions to the moon, including, for example, the Viper rover to the South Pole region. And then there are about a dozen missions that have completed their mission, and we have archives for those. Next slide, Tom. This slide just shows our front page to our website. You could browse it at your leisure, but it on the left has navigation through the missions that we have data for, announcements in the center, and so forth. Each of the missions we have data for has a landing page, and within those landing pages of the mission, there's a landing page for each instrument. And this navigation provides a simple way to get access to the data if you know what you're looking for. But as I said, we have over 250 terabytes and several tens of millions of products, so it's not very effective if you're not sure what you're looking for. So as a result of that, we've developed several tools to help people navigate the archives and find and download what they need. So next slide, Tom. So on this slide, just another note, we do like to interact with our community. We have several ways of doing that. We have a forum where users can post questions, and the idea there is that not only will node personnel answer questions, but other people in the research community, if they've had these questions themselves, they can help answer the question. And then when we do get questions from users outside the forum, we tend to post the answers there. So it's building up an archive, if you will, of information about how to use and access data within the node. We have several email addresses for people to contact us, and we have the presence at science conferences such as the Lunar and Planetary Science Conference, where we demo our services and love to get feedback from users that help us prioritize how we're going to make improvements to our services in the future. Next slide. Okay, just briefly, the three things you're going to hear about from my colleagues in a few minutes. The first and newest service is the Spectral Library database and the interface into that library. We started this project through the PDART program, working with the investigator who manages the Reflectance Laboratory, or RELAB, at Brown University. And there are several tens of thousands of spectra that have been collected over many years that we've brought into the PDS as an archive and built a searchable interface to access that data. So Dan will talk about how you could do facet-based searches, scan through those spectra that you find. It has a way of doing interactive plotting to visualize the spectra, and then you can download individual data products or load up a cart of several data products and download them. Next slide. The second tool is the Analyst Notebook, which is designed to access data from landed or rover missions. And it provides a integrative approach of not only searching the data or browsing the data, but it provides information from the missions on planning documents and reasons for acquiring data. It has ways to search by time, location, or targets, named targets that data were collected for. And it can display data, both image and non-image data, and for images, actually do some measurements like distances between targets, profiles, if there's topographic data, and so forth. Next slide. I think this will be my last slide. The third tool is the Orbital Data Explorer, which is designed to search and access data from orbital missions. Right now we have 4 of these organized by target: Mars, the Moon, Mercury, and Venus. You can search data in various ways, including drawing polygons on a map to find data within that polygon. It has a REST interface so that if you don't want to use the web browser interface, you can actually write scripts to access data within the archive. And Dan will talk about this thing called Aspera, which is a way to have high-speed downloads for some of the large data sets. One of the interesting aspects of ODE is that we collect metadata from various PDS nodes that have relevant data, and so you can search for products that are housed at other nodes, and if you select them, ODE will copy them from the other node and deliver them to you. So it's kind of a one-stop shopping, so you don't have to go to several different nodes to find the data you need. And I think that ends my part of the presentation. Yes. So now I'm going to turn over it to Dan Scholes, who's going to talk about, as I said, our newest interface, the Spectral Library.
Hello, everyone. My name is Dan Scholes. As Ed mentioned, I'm an application developer at the PDS Geosciences node. So I did the interface work on the Spectral Library website and database. So I'm going to kick us off. You want to go to the next slide, Tom? Okay, so what we did was we created this as a simple, user-friendly interface so that users can search, find, review, and then download data, laboratory spectral measurements that are archived at the PDS Geosciences node. Navigating around, as Ed mentioned, in folder structures is pretty daunting, and so this is an easy way to organize and find what you're looking for. We released this interface in April of 2020. We currently, as Ed mentioned, we have Relab data, the database of Relab from Brown University with almost 17,000 measurements. And we're working to add additional data sets into the system. Right now I'm working on a Raman data set that once it's released to the public through the PDS Geosciences node, then I will integrate it. So that's going to be an exciting update because it's going to add new features, enhancements that are going to help both the reflectance spectra that we already have in there from Relab and then this Raman data. Want to go to the next slide? So some of the major highlighted capabilities include that faceted search for immediate results, which I'm going to demonstrate. We have a quick view capability where you can compare measurements from the results list, and on detailed pages where you can actually see the measurement information and then also about the specimen. and download affiliated files, download a plot that you created based on the options for editing it as far as the range. And then we also have multiple download capabilities. You can download individual files from the detail pages, or we have a cart system where you can grab everything at one time. And I think that's what most folks will do. All right, I'm gonna go ahead and jump over to the demo. Let's see. Okay, this is the home page of the PDS Geo Spectral Library. On this home page, we would list all of the databases that we have available through the interface. So right now we just have Relab, but this list will grow with more information about each one so users can select if they want to immediately filter down to just one database, or they can select them all. So we're going to go ahead and select Relab and begin our search. This is the primary search interface. As you can see on the left, we have our filters, which it looks like a lot of other, e-commerce websites with a faceted search that can immediately update our result list. So right now, at the top would be the different spectral databases that are available. We have Relab selected. We have keyword search, and then we have a number of other options. We have meteorite data, terrestrial samples, synthetic samples, lunar samples. So as I toggle these, you will see the numbers change as far as the counts. Let's see. As I toggle this, you can see all these numbers change, so you can get some immediate results. Let's go ahead and just put in Mars meteorite. Okay, so we have olivine in here, and we're down to Mars meteorites. So as I mentioned, this list of filters is going to continue to grow as I add additional data sets in and we see what makes sense, and we get additional feedback from the user community. On the results list, you'll see the filters that are applied are just these little boxes that you can click and it'll remove that, that filter. The list first shows the specimen that we have cataloged, and then if you expand out the specimen, then you can see the specific measurements of that specimen. So sometimes if you apply certain filters, for example, a measurement range, that might filter out these larger ranges. But you'll see a little option in here so that basically you can still see that other measurement if you want. In fact, I can show you real quick. Here's that example. So we're just showing the ultraviolet range right now, but if we want to see other measurement ranges, then we can click that toggle. So let me go ahead and remove that. We'll get back to where we were. From this list, we can actually compare a couple of these measurements with a quick view on the right by clicking on the thumbnail, and then it's going to plot them together. And then you can mouse over, and as you can see, it'll show you the actual measurement values as I'm moving along the plot. We can also apply filters for the ranges. Let's just do 10,000 to so then it'll just redraw it, and then you can actually download this graph, or if you want to download the actual data files that created this, you can download it by clicking there. Back to our result list, we can add products to the cart by simply clicking the checkbox, and as you can see, that updates our cart contents. Now we can also view the details of these measurements by clicking on the hyperlink, and that opens a new tab that shows the measurement details. And as I mentioned before, at the top we have the specimen metadata, and then we have our measurement metadata, which is visible here. Then at the bottom we have the the label file and the data file, which could be downloaded directly. I've added this already to my cart, so it's indicating that it's in the cart. Now, we have the ability to track thumbnail images, ancillary, well, pretty much any kind of ancillary file that the data provider wants to associate with this measurement. So if we do have images of the specimen, we'll see thumbnails here that can be clicked to view a larger image. And we also have the capability to track references if for the actual measurement or the specimen, and references would be listed down below. Now, a couple of features that I like about the detail page. One is you can click this little icon to immediately see what filters you've applied for these result lists. And also you can scroll through your results by clicking this next and previous. So that way you don't have to go back to your results list if you have a small list that you're interested in working through the list. I'm going to go ahead and close this and go back to our result list. The other major feature, you can add all of your results to the list by clicking this Add All Results to Cart. So that way you don't have to go through each one and select it, or you can also remove. Then if you want to download your cart request, just click that cart. It'll take us to a download page. And from there, you can see the result list of the specimen and measurements that are in your cart. You can see that here, and you can make edits if you want to deselect some. And then you can select what format you want the files to be packaged in. And then you would enter your email address. And then what'll happen is it will, behind the scenes, it'll send off your request to a processing server that will collect all the files that you requested. And it will package them into a zip, a tar, or tar.gz file. And it also create MD5 checksums to include as well. And it will email you a link, an HTTP link to download the checksum file and the actual zip tar.gz file. So then you can download your files and be on your way. So that's pretty much a quick overview of the Spectral Library interface. This one is a little shorter than the ODE or the Analyst Notebook review walkthrough demo because this is pretty straightforward. There's not a lot of pages. I guess I'll go ahead and turn it over to Tom for the Analyst Notebook.
Yeah, Dan, while Tom is doing that, I just wanted to say a word about nomenclature. In the spectral library, we're using the term specimen to indicate a physical object that was measured, and measurement to the actual measurement. And we tried to avoid the term sample, since sample has a connotation in images and so forth. So that's the terminology we're using there, and hopefully that was clear to people.
Great, thank you, Dan, for that. So we'll continue on with a brief discussion about the Analyst Notebook and demonstration. So as Ed mentioned earlier, the Analyst Notebook is designed to synthesize and integrate data along with documents and other value-added components to let users step through landed missions on Mars and also for Apollo and LCROSS. So the concept is, as Ed mentioned, you can kind of step through these websites that we've seen historically up with the white background and the blue file links, but really to kind of hone in and do discovery, having thumbnails and just really putting things into context makes all the difference. So as we see on this slide, we have notebooks right now for InSight and NSL Curiosity. They're ongoing. Also for MER, Spirit, and Opportunity rovers, the Phoenix lander, LCROSS, which did land, and Apollo. And these notebooks have varying levels of tools and so forth that we work to update and upgrade commensurate with requests largely from the community. What kind of things do our users seek, and what helps them get the most out of the data to further their science? So as has been mentioned, feedback is always welcome and really appreciate the feedback we've had from the community so far, because it really makes a difference and helps direct our efforts. On this slide, and some of the other slides that we've had in this presentation, they're there for you to also go back to. So I'm not going to speak to everything on this slide, but the takeaway here is that the notebook has quite a few capabilities and just different ways of looking at data, at documents. And in this case, what we mean by documents is not only the archive documentation about a data set or the format of the data and so forth, but documents produced by the science teams for Curiosity, Insight, Opportunity, and Spirit, and Phoenix. We've captured those day-to-day documents written by the mission managers and the documentarians. So that really helps users step through kind of what was the intent behind some of these observations. And that's what we're really trying to capture is intent and context. We also pull in the targets and the plans that are produced, and also mosaics, which are data products, but kind of have a special weight to them that can provide additional context as people become familiar with certain landscapes. And then at the bottom, you see that there are a number of additional capabilities that get thrown into the notebook. And I like to show this view of the notebook because what we really try to do is to take that standard PDS release of data on the left side in gray and add to it these value-added tools and elements, different ways of looking at data, previews and views, and really just add the documentation and the resources to help people better understand the mission that's being presented. So, and finally, we do have a number of folks who reach into the notebook metadata to support external tools. Google Mars has looked to the notebook for some traverse information, and we have a number of other users who reach in for metadata. And then also in return, some of their work gets pulled back into the notebook, and I'll speak to that in the demo. So I'm pretty sure this is where we step in. Yeah, we'll step into the notebook here. So let me switch the screen over to that. So this is the landing page for the notebook site in general, with links to individual notebooks. We'll be adding, as Ed said, Analyst Notebooks to support Mars 2020 and also for Dragonfly in the future. For this demonstration, I'm going to go ahead and hop into the Curiosity Notebook, although we'll see quite a lot of similar functionality in the other notebooks. So here in a nutshell, I'm already logged in. I can see it's telling me my account name, and while anyone is welcome to use the notebook at no charge, and you can even use it anonymously, when you sign in with an account, you get a few extra bonus features, if you will, of maintaining your search history, so you can come back and see what you've looked at previously, and if you've placed data orders, those get maintained, and then personalized settings that a couple might come up here during our demos. So the concept here on this screen is that it's through the web browser, but it's really a web application. So hopefully you're staying on that one tab and looking at it kind of like this giant electronic notebook with these tabs down the side. So they are representing the mission overall, and then we'll jump through these others, the Sol view, searching, looking at maps, resources, things that are special to and unique to individual users. And then, of course, this last tab of help to go through our online help and to find out other information, including providing feedback that gets back to us. When on occasion, the notebook doesn't quite work the way we expect, or maybe we need to tweak something. So that help is always important. From the mission summaries, we have a couple of options here. This historical overview is really a day-by-day kind of one, maybe two lines about the activities going on for each sol, and a little bit of extra help information about where the rover was and what time it was. And this list can be viewed and downloaded, and also used as a way to jump to a particular sol within the mission. This is just, one way of looking through the mission and kind of getting a flavor of what was going on over time. And then these the science targets list presents the targets that were defined by the science operations team, and is a quick way to get into the science targets. In both these cases, these tables can be sorted and searched and narrowed down to give views of interest. But as always, there are links to jump around into the notebook. So that should hopefully help make things a little bit easier to go from place to place. Let me go ahead and close these out just because I like to keep things a little clean here. Now the sol view starts out with a, at least for a beginner, what might seem like just a little bit of a sort of complex block of information. It's kind of all tightly packed together, kind of like those early 1990s websites where everything was just smushed and smacked in and kind of had a code to it, but it hopefully is easy to decipher with a moment's look. What we see here is for these 3 sols on Curiosity, we see the time here on Earth, but there's that one-line description of what was going on, the number of data products, documents, activity plans, targets, mosaics, so forth. And then this block of colored boxes represents the science instruments on the rover, where a filled-in block indicates the presence of data returned by that instrument for that sol. So if we go ahead and open up that block, we can start to drill down into these different units of data products and so forth. This sol overview shows a little snapshot of the traverse map. We can see some time information, and then put into context this sol and activities of surrounding sols, and then just the number of data products that are coming out. And from the data product view, as we open that up, we can see in time order the data that were returned with some thumbnails. You can see sometimes some products right now have blank thumbnails because the data are sometimes not represented easily as graphs, meaningful graphs, or as images. But where there are images, we see the image, and by clicking on a product, we can go in and look at that product in detail. I, in fact, wanted to kind of jump down a little bit farther here, where kind of getting into later in the sol. Here's this navcam with a few extra bits of information that tell me that this image was used to define a target. That's this this location or target symbol, and the what's supposed to be a ruler. Sometimes it's hard to kind of make these things out. Indicates that there are measurements that can be made on that. So as I look at this left image, for example, I can see that image was used for a number of mosaics that can be viewed, and we can click on one and jump to it. Was the kind of finder frame, if you will, for these 2 targets of Gleneagles and Gleneagles, the ChemCam target, and so we can see that those targets were defined there, and then we see the browse image of that was taken of this observation, and can jump into some other views. In fact, we could, for example, say, let's take a look quickly at this image with the 2 targets that were defined there, and you can see that here being presented. Let me jump back here through this product menu. There's a whole number of views, such as the PDS label for this product that can be viewed and downloaded. And then also, I'm going to jump back to this overview quickly to look at this length of this full image with 2 tools. So this is this image viewer that Ed had mentioned, and in this view, we can make some measurements. It looks like I've already got one that, as when I was logged in earlier, I made a profile along here from point 1 to point 2, and can even see that. Here it is loading up and shows me. In this case, there's not a lot of elevation difference, but I can see working across there what the profile looks like, and in some of these navcam images with views further afield will demonstrate maybe a little bit more usefulness for this tool. The targets are also shown here, and in this case, I've got the visibility turned off for this second target, but the point here with this imaging tool is that one can look at location information, see where the targets are plotted, and go ahead and output this this image to a file, or just download all the information that's annotated on there, including points of interest if a person wanted to come through and add a new location. Here where this purple mask is the keep out zone. I'm just going to click here on this this spot, and I can get the location, not only the IJ pixel on the image, but the location in site frame, or switch over to local frame or rover frame, and these kind of concepts that have meaning within this particular rover's coordinate system. Okay, so in addition to that, we can go ahead and look at targets. I'm going to jump back here to so there are 3 targets that were defined on SOL 2577, but we also found these targets that were defined here with this image. And in this case, for this Glen Eagles target, we could show other images of this target. So these images, all within 50 meters of where that target exists, shows the data product, so that we could jump in and take a look at maybe this. Here's a mass cam product, and show where the targets are on there. So you know, that's another useful bit of kind of tying together all of these concepts and so forth. I wanted to show the documents. Here's the mission manager status report that can be read, and that conveys a lot of information. We could look at activity plans and targets, and let's pop over here to search for a minute as the time winds down for this particular demo. Like the spectral library, the search is a faceted search where one can constrain the search parameters, maybe by SOL, by the type of information, maybe only mass cam or only navcam data. And there are a number of other filters here. And once you find a product, you could open it up for more information. You could add it to a cart, which I could do even here from the SOL view. I could say, hey, give me everything from SOL 2577 and throw it into the cart. So I'm going to just continue here. So we have in the data search, we have target search as well. Here's finding targets with related data, like this target that has APXS and KimCam data links and so forth. And then here's the rover map, traverse map, another way of getting to the data by clicking on location, and then from here, again, the data pop up in a similar fashion. So a lot of ways to work through the tools and work through the data, and hopefully help with discoverability and just a better understanding of the mission data and working through. So as always, please give these things a try, and if you have some feedback, we'd love to hear it and get some direction on the best ways to present the information to the users. So with that, let me go ahead, Dan, and throw this back to you for...
before you leave that,
yeah.
Could you show an example of a non-imaging data product that you might be able to visualize?
Sure. Yeah, here's an APXS reading from this particular target of Abigadasset. I think that's how it's pronounced. This is a ratio plot that the APXS team was really kind enough to give us some information on the best way to present the data. And that's something we really try to do, is to work with the science teams, instrument teams, to make sure that we're presenting the information in a correct way, but also a meaningful way. And then these data can be downloaded. And we did, just for MER, for Opportunity and Spirit, put in links to the target database that is just generated by the MER science team and some folks here at the Geosciences node into the archive. So the target search that I'm showing here for Curiosity is now available also for Spirit and Opportunity, with links to APSX and Mossbauer and RAT and microscopic imager data as well.
Okay, thanks, Tom. This is Dan again. I'm gonna talk about the Orbital Data Explorer. If you wanna go to the next slide, Tom. So we created this interface as a cross-mission, cross-instrument data search that we catalog data from both the Geosciences node and other PDS nodes. And we have this is all for orbital data, of course. This is for Mars, Mercury, Venus, and Earth's moon. And one of the major objectives, in addition to the searching across multiple PDS nodes and instruments and missions, was the capability to download products all from one PDS products all from one location. So that's something that we've integrated throughout the system. You want to go to the next slide? Some of the major functions which I'm going to go through include the form-based search. We have an interactive map. We have detail pages for the observations or PDS products. And I'll let you read over all these details later, because I'm going to walk through it in the demo. We also have multiple download options, as I mentioned, both directly or through a cart. We have MRO coordinate observation search, which a number of people have found useful, where you can see the actual PDS or the observations that were taken at the same time in a coordinate observation on MRO. We also have what we call a granular data search, which is basically the capability to do a subsection of data points within MOLA, LOLA, Diviner, and MLA. So that's pretty useful to help create various process products on your end. And then we also have an ODE REST interface that a number of users are ingesting data from ODE for other systems or just for their own lab use. So you want to go to the next slide? This is just a simple diagram demonstrating that basically we ingest the data from the PDS archives, and then we use that to load our map servers that we use through the ODE interface, which I'm going to show you, and our metadata database. And then we use those data sources for the ODE website and for the ODE API. Okay, why don't I go ahead and take it over, and then I will show us the walkthrough. Let's see. Hold on one second. Okay, this is the ODE landing page. From this location, you can see we have the 4 versions: the Mars, Lunar, Mercury, and Venus. For this demo, first demo, we'll go into the Mars Orbital Data Explorer. So from that home page, you can see we have these tabs across the top that are used for navigation, and we also have links here on the home page. You can also navigate to the other versions. I'll start off with, we'll do just a regular text-based product search, and then we'll get into the map search. So from this page, we group together the data sets by mission, instrument, processing level, and product type. So I want to do a demo of, we're going to search for some MRO observations that are over Gale Crater. So we expand out the mission, and then we see all the instruments that we've cataloged in ODE. And we will go ahead and select Prism TRDRs, and you can get to more details about each one of these product types by clicking on a description link. That'll go to a help page that breaks down information that we pulled from the product type sys. And then we also have these icons to show that the little map that it's map projected, and then the little clock to show we have time, observation time information. Then we have observation angles and solar, I guess that's solar longitude is that other icon right there. Actually, there's the key right there. We're going to go ahead and pick out CTX. For CTX, we only have EDRs in the PDS, but we also have the ability to link to these non-PDS RDRs that are available through ASU's Mars Space Flight Facilities Image Explorer. So we're able to use their service to download the more processed versions, and that's available through the cart checkout process. We come down here, we're going to go ahead and select these high-rise RDRs as well. So we're going to do a search across those 3 product types, but you could also select other missions and instruments. That would be just fine. We have additional filtering options. As many of you probably know, if you're familiar with the PDS, that product IDs typically have some kind of pattern to them that's associated with a particular mission and instrument product type. So that can be another filtering option. We have this where you can enter multiple product IDs or filters with wildcards. So a lot of people use that if they have an idea of a specific product they're looking for or a pattern. So that we have that available. We're going to just stick with the location search for this demo. So we just have a drop down. I'll go ahead and get Gale in here. And that will, this list of features is the standard feature list that the USGS posts, which is mentioned on the other slide. It's the International Astronomical Union Working Group for Planetary System Nomenclature. So that's where this list comes from. So you could also type in your own bounding box here. Now we also have the ability to use an interactive map if you want to select your area of interest this way. This was a newer feature I added last year. And so with this ability, then you can just zoom in on a particular crater and you can actually even create an own freehand polygon. So that's another capability that we have. We can also filter by observation time or creation time. We're just going to do an observation time of 2018 to 2019 for this example. And then we also have these other observation angle filters and Mars year, solar longitude. We have a button here where we can get a summary of the results. So that way we can get an idea right off the bat if our search is going to be valid or if it's just giving us way too many results. So we did a sandy check and 89 products sounds pretty good. If you look here on the list, we can also now, we can either do the search in the results table or on a map. So we're going to do the results table. So here's our results list. From this list, we can sort the result list, we can page through it. If we end up deciding that all these products are ones that we're interested in, we could add all the results to the cart with a single click here. We could also output the list as a text file, which will also include direct links to the products, or we can view it on the map, or we can go back to our search. Later, we'll view it on the map, but let's start off by looking at the details for a few of these products. So click on the product ID, bring us to the product detail page. From this product detail page, if you look at the top, we describe what kind of product it is, and we expand out this for more details about the product description. We provide links to the PDS archive documentation files. So this gives us links to the documentation files about this PDS product type. So that's a useful resource. We also show a browse image, and then we provide links to download the file directly if we want. We also have metadata, just general metadata, the primary metadata about this product that we list. And then we also have processing notes about how we process it into ODE if we had to set a few of these fields based on different sources to get it normalized into the system. We show the product label. Then related products, I'm going to get into this a little more later, but this is showing that this product was coordinated with these other MRO observations. So that would be an option. And also, if when we're on a different product type, if this product was used to create higher level products, or there were raw products that were used to create this, then you would be able to see those related products in this list. So that can be helpful if you want to go back and see the original or higher process versions. We also have a context map so you can get a quick idea exactly where this observation is. If you want to add this to the cart, you can just click it here, or we can add it over here. Let's take a quick look at a CRISM product. We don't have a browse for this, but I want to demonstrate that if it's a product that's archived at the PDS Geosciences node, we have this button for downloading via the Aspera browser plugin. And let me talk a little bit about Aspera. Ed mentioned Aspera earlier in the presentation. This is a software that we have a license for. It's similar to what they use for Netflix streaming. Basically, it uses some different protocols so that it can better utilize your bandwidth than just standard HTTP or FTP. So we have a licensed server, and then if you want to use it, we have there's a free plugin that you would download. If you click this link, it will prompt you to install the plugin. And that will install the plugin on your browser, and then it'll install a light client on your PC or your laptop, your desktop, or your server if you're running this from a server. And then when you initiate a download, which I'm going to go ahead and do here because I already have the software installed, it's going to initiate via that protocol, and it's going to start downloading this file. So this is almost a 50 megabytes file, and it's downloading pretty fast. And I can show you real quick. It puts this little client. Can you guys, Tom, can you see this client that I popped up?
No, I cannot, Dan.
Okay, I apologize. Well, with the Zoom, you can't see this little client that popped up out of my tool tray bar, but it will show you the progress, and you can tweak settings. But basically, we've seen some users achieve almost a 20-time performance increase in speed on downloading files, depending on their institution, their network. Now, from a home network, you'd easily see a 4-time increase in speed over HTTP, FTP, but your mileage may vary depending on your institution. But this will allow you to download all those files affiliated with a product with one click. All right, let's go ahead and pick up the pace here, but I'll add this product to my cart even though I'm downloading it that way. So here's our list here on the left of all the observations or PDS products for that site of interest. We can view it on the map by clicking this View on Map button. This is going to take us into the map search, which is similar to if we had clicked this map search button up here on the toolbar, but this is already filtered based on our product search. Right here is our Gale crater, and we will see here's the list of products that we have in our result list. If you mouse over a product here in the result list, you will see that it highlights its footprint on the map. So you can go through, you can click on one of these and it'll products, and it'll bring up the detail page for that product. Up here on this bar, you can see there's additional filtering options. One of my favorite options right here is display only products selected by area, and you can select that, and then it will limit your results to only what you only products that intersect the area that you selected. Now, this results are pre-filtered to the layers from our from our product search. So these layers correspond with what we saw on the first product search page. So we could actually toggle in other layers if we want, or turn them off on. Let's go ahead and turn on the charade RDRs. Now they're a little hard to see, so I will use this option to make the lines a little darker. Still a little bit hard to see, but you probably make out the line right there. If I go back to this tab here, the view selection results, or click this little pop-up, it'll get us back to the result list. And I think the charade products will be at the end of the list. And if I highlight them, then you can see the darkened line here. So those are the charade products that intersect our location. Now up here on this menu of different mapping features, we can actually select our own little custom freehand polygon. So let's go ahead and do that so we can more narrow our search results. Or actually, let me just do this. Yeah. So now you can see we're down to even a smaller set of products. And we could add them all to our cart by clicking that, or if it's a long list, you can click that button. So we've seen there's the select layers option. So these are the available product footprint layers in this section. We have a feature layer that those are those named nomenclature that we discussed. You can toggle that on and off. And we also have additional base maps that can be turned on and off. And you can adjust the transparency here as well if you want to tweak it for your situation. We have additional filters right on the second tab. So right now, as you can see, I have it filtered to 2018 to 19. You can edit this and hit apply filter, and that'll change the results. In fact, I'll try to do that for us. We'll do 2016 to 2017. Let's just see what kind of difference that makes. So as you can see, that gives us some different products. So I'll just add a couple more of these to our cart. Basically, then we could go back to our text-based search if we wanted, but this is based off of the modifications I made for our last part of the search now. We could go to the map search, but this is what we basically just saw. But if we go to the map search tab, it's just bringing us in here fresh, where as if it doesn't have any filters applied already. But I think you have the idea from how we interacted with it from the other search tab. But you can get into here, you can turn on and off different layers, do the different additional filters, and then view your search results. So let's go ahead and go to the cart real quick so we can see how that part works. And then we're going to swing back to some other features real quick. So now we're on the download cart option. From this page, you can see there's a summary of how many PDS products we have in our cart and what the size, and then you can see your result list. And that second section gives us additional options. For some of those CRISM products, there are affiliated files that you might want to select. So we might want to do that. As I mentioned, in the PDS, we only have technically the EDRs of CRISM products, but we could also select those non-PDS processed versions from ASU. So here we might select TIFF. So it'll add that to our cart request. There we could get derived files that we produce at the Geosciences node for individual footprints of product files. So if you want that, select that. It'll give you a corresponding footprint file for every one of the products in your cart. Then we have the mini archive file option. So if you select that, it'll give you all the documentation that goes along with those archives of the products that you selected. Then it'll give you a total size of the cart and an estimated time of download, but it's much quicker than that typically. I want to show you that we also have this advanced feature. With this cart process, we limit the download size to about 50 gigabytes so that our systems don't get overloaded, especially when we're acquiring files from other PDS nodes. Because what happens if you request files from these other PDS nodes, we will download it behind the scenes and package it all up on a site. And then once we're done organizing it, then we will email you a link to that page where you can download the files at one time. But if you have a very large cart request that is going to be over 50 gig and you don't want to break it up into chunks, there are these advanced options. Let me click on that and show you real fast. On the advanced options, you can download basically your cart result list as an HTML file. And what that would do is you can just save this list with hard-coded links, which you can download any of these files at your leisure later on. So that's one option. The other option is you can download a text file that will give you a result list of all of the HTTP links to the product files in your cart which then you could use like Python or wget or curl to download those files directly to your location. We've had a number of users that have enjoyed this feature, and it was actually suggested at LPSC at our booth. And so I integrated it, and that is another way that you can just download the files directly. Let me go back to our cart. So say we want to go ahead and check out. We go to this checkout page. We pick out if we want the files packaged into zip, tar, gz, or just no compression. If you select no compression, it'll just be in a directory structure on the location where you're going to be able to download. Then you would select you want it organized into a PDS archive structure that emulates the structure that the files were in, or do you want them all in one directory? And then you put in your email address, you hit submit, and then it runs off and works. And what it'll send you is it'll send you a link. This is a sample ODE cart page. So it'll send you a link to a page like this, but it'll be specific to your cart request. And from that page, we have these options for downloading the files. We have that Aspera plugin integrated in here, where you could just install Aspera, click this link, and it will just download the entire archive to your downloads directory on your machine. Or we have an HTTP link, so you could get to just an HTTP link structure that you could use other tools to download the files, or there's just the traditional FTP link. Here's a list below of the actual individual files, and from that you could click a Aspera link to just download that file, or an HTTP link to download the file. So we have our email address and help on this page. So if you run into any problems with it, just email us. I'm one of the people on this email, and we'll respond to you as soon as possible. So let me see how we're doing on time. I'm running a little over. Tom, do you want me to keep running on a couple more things, or?
Dan, I think let's show this links and support list to folks, and then give them an opportunity to ask questions, and then we can jump back in if we've got some time.
Sounds good. Why don't you go ahead and take it over?
So Tom, yeah, I could speak here. So here's a link of access to our general website and the 3 tools that we've been demoing on the left. And then if you want to contact us, there are several links that you could email to. And these links are also on our web page. So there's the forum, there's the Geosci is a general email address if it's your question is not related to one of the tools there. And then there's individual addresses for each of these tools we talked about. So if your question is related to the tool, you can email to that address, and you know that the people who understand those tools and work with those tools at our node get the question directly to them. So, and that's in your package of slides if you need to refer to that. I guess we could open it up to questions if there are any, if people can stick around. And I'm not sure how that works within this Zoom program.
I believe
Dick Simpson with a question.
Go ahead, Dick.
Go ahead, Dick.
Insight is one of the few missions that's archiving directly to PDS4. Most of these tools seem to be heavily dependent on PDS3, or at least the language is PDS3. I was wondering how far along you are on adapting all of the tools to PDS4, because things like, I think, Mars 2020 probably will be entirely PDS4.
Tom, you want to take that for Insight?
Yeah. Yeah, we are able to handle both PDS3 and 4 data. I know that Dan has done that in with ODE, and then here just briefly sharing out the Insight notebook. You know, it's a lot of the same look and feel. So early on to a lot of users, you might not even really notice the difference between PDS3 and 4, which is, you know, part of the key, at least you can get into the PDS4 metadata and can be more useful to some automated scripting and so forth. But we do incorporate PDS4 and PDS3 data together into the tools.
I'll just add, Dick, that we've migrated messenger data, and that's part of the Mercury ODE, and have modified ODE to handle the PDS4 terminology and labels. And then the spectral library, those data products are all PDS4. So the metadata used to drive the interface is all PDS4.
That sounds great. Thanks very much.
Hi, Tom, Don, this is Mitch. Spectacular as always. Do you have to generate any additional metadata over what is delivered by the missions for either the ODEs or the analyst notebooks?
I'll take the first cut and then let Dan add on to what he has to do for ODE, because I know it's a bit different. We do incorporate the data coming in from the missions, from the archive, but then also working together with the mission teams are able to acquire and use non-ITAR, non-restricted information, but data that they're not part of the archives, including some of the documentation. And we do incorporate that. And then we also encourage the teams to create formal archive products when we can, such as the MER target list that's just being wrapped up in peer review right now, to put those into the archive. So for the notebook, we don't expect it to go away, but if I get run over by a pizza truck, we want to make sure that there's nothing special that the notebook knows that other things don't. But as folks know, when you're very focused on one instrument for the work that you're doing, it can be challenging to put the information into the archive initially in a way that can be linked up with other data. And so those connections that we add, we work to put into the archive, but yes, there's additional work that does get done.
I'll speak to the Orbital Data Explorer. We do generate browse images in some cases, but obviously we're using the actual PDS data product to create the browse image. We create those footprint files, but of course that's based off of the metadata that's provided for the footprint for the product. So yeah, the only thing I would say would be that we're generating a few ancillary files based on the actual data. I think it's usually pretty clear what it's created, and it's just a direct correlation. And on the spectral library, I create, the little plot thumbnails, but I think that's about it. So I guess back to your question, I don't think we're really creating much that's very noteworthy on the ODE side.
Dan, a follow-up on ODE. Isn't it true that for some data sets you do have to generate some geometry or time information to normalize it to the database that's behind ODE? You showed the processing notes, I believe it's called.
Yeah, we do show the processing notes. Yeah, it would be directly generated based on the metadata that's provided. And footprints, we've had to pull that from multiple locations. Sometimes that's in a PDS index file. Sometimes we're pulling it from the pilot database from USGS. But all those notes are always in the notes field on that product detail. And then
Other questions?
one last thing, we also generate those footprints into our own map servers.
Well, if there are no other questions, thank you everybody for attending. And if you think of things after this workshop, use any one of those addresses to contact us, and we will get back to you. So thanks for attending, everybody.